Myself, Yogesh AM, working as a selection grade lecturer in the Department of Electrical and Electronics Engineering. In the last class, we have learned about the load sharing on a three-phase alternator when they are connected in parallel under different conditions. The first condition is what is the effect on unequal voltage of two alternator when connected in parallel, and what is the change in excitation of any one of the alternator and how the system will be behave, and if you are changing the prime mover of an alternator, what is the effect. So all these things we have discussed in the last class. Today we are going to discuss about the meaning of hunting and how this hunting is prevented. All these things will be discussed today. So what is the definition of hunting? So hunting is nothing but suppose when a sudden load is applied to the alternator. So it will be hunt or search a new equilibrium position in order to stabilize or in order to withstand the application of load. So in order to achieve the stability, the speed of the rotor will be fluctuating or oscillating. So this process we can be called as a hunting. So the one more definition of hunting is the phenomenon of involving the oscillations of the rotor about its final equilibrium position is called hunting. ಸೊ ನಿಮಗೆ ಅಂಟಿಂಗ್ ಅಂತ ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂತ ಅಂದ್ರೆ ಸೊ ಒಂದು ಜನರೇಟರ್ ಅಥವಾ ಆಲ್ಟರ್ನೇಟರ್ ವರ್ಕಿಂಗ್ ಕಂಡೀಷನ್ ಇದ್ದಂತ ಸಂದರ್ಭದಲ್ಲಿ ಯಾವುದೇ ಲೋಡ್ ನ ಕನೆಕ್ಟ್ ಮಾಡ್ದಲೇ ಇದ್ದಾಗ ಸಿಸ್ಟಮ್ ಯಾವ ರೀತಿ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇತ್ತು, ಸೊ ಸಡನ್ ಆಗಿ ಲೋಡ್ ಚೇಂಜ್ ಮಾಡಿದಾಗ ಅದು ರೋಟಾರ್ ಮೇಲೆ ಯಾವ ರೀತಿ ಇಂಪ್ಯಾಕ್ಟ್ ಆಗ್ತದೆ, ಆ ಇಂಪ್ಯಾಕ್ಟ್ ಅಂತ ಆದಂತ ಸಂದರ್ಭದಲ್ಲಿ ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಚೇಂಜಸ್ ಆರ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಸರ್ಚ್ the new equilibrium position in order to stabilize the system for the variation of the load. So such oscillations in order to hunt for the new equilibrium position, we can be call it as a hunting. So the word hunting is used because after the sudden application of the load, the rotor has to search or hunt its new equilibrium position. When there will be no load, the rotor will be behaving in one position. Suppose if the system will be suddenly loaded, under that condition, so that heavy load will be swings on the rotor and it has to withstand, in order to withstand the stabilization, so it has to hunt for the new equilibrium position. So let us know how the equilibrium will be taken place in case of a synchronous generator. So first we should know what is the steady state operation. A steady state operation of a synchronous generator is a condition of equilibrium in which the electromagnetic torque developed on the rotor is equal and opposite to that of the load torque. ಸೊ ಲೋಡ್ ಟಾರ್ಕ್ ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಏನು ಒಂದು ರೋಟಾರ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಟಾರ್ಕ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ ಅದು ಈಕ್ವಲ್ ಮತ್ತೆ ಆಪೋಸಿಟ್ ಅಲ್ಲಿ ಇರ್ತದೆ. ಸೊ ಸ್ಟೆಡಿ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಯಾವಾಗ್ಲೂ ರೋಟಾರ್ ವಿಲ್ ಬಿ ರನ್ಸ್ ಅಟ್ ಸಿಂಕ್ರೋನಸ್ ಸ್ಪೀಡ್. ಸೊ ರೋಟಾರು ಸಿಂಕ್ರೋನಸ್ ಸ್ಪೀಡ್ ಅಲ್ಲೇ ರನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಮೇಂಟೈನ್ ಇಟ್ಸ್ ಲೋಡ್ ಟಾರ್ಕ್ ಆಂಗಲ್. So the torque angle in the initial condition under steady state condition we can be referred as delta. So when the system will be in the stable condition, under that condition the torque angle will be delta. So let us consider, suppose if there is a sudden change in the load torque. So load torque sudden ಆಗಿ ಚೇಂಜ್ ಆದಾಗ ಏನಾಗ್ತದೆ, the equilibrium condition ಇದ್ದಂತ rotor will be disturbing. ಸೊ ಡಿಸ್ಟರ್ಬ್ ಆದ ತಕ್ಷಣ ಏನನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತದೆ? ದೇರ್ ಇಸ್ ಎ ರಿಸಲ್ಟಿಂಗ್ ಟಾರ್ಕ್ ವಿಚ್ ಚೇಂಜ್ ದ ಸ್ಪೀಡ್ ಆಫ್ ದ ಮೋಟಾರ್. ಸೊ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಸಿಂಕ್ರೋನಸ್ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ರನ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಸಡನ್ ಆಗಿ ನಮಗೆ ಸಿಸ್ಟಮ್ ಮೇಲೆ ಲೋಡ್ ಅಪ್ಲಿಕೇಶನ್ ಜಾಸ್ತಿ ಆದಂತ ಸಂದರ್ಭದಲ್ಲಿ ಸೊ ಮೆಕ್ಯಾನಿಕಲ್ ಸ್ಟ್ರೆಸ್ ಬರ್ತದೆ. ಅವಾಗ ಏನಾಗ್ತದೆ? ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬೀನ್ ಡಿಸ್ಟರ್ಬ್ಡ್. Suppose when the synchronous machine will be work under unloaded condition, the load angle will be 0. Suppose if the load will be increasing, the shaft will be start rotating fastly or slowly according to the fulfillment of the load. So due to this, the load angle will be increasing. Suppose let us consider P1 is the load applied to the unloaded machine. So once if we are applying the load, the shaft will be start rotating slowly. Because of the application of the load, the suddenly the rotor speed will be come down. Also the load angle is increases from 0 degrees and becomes delta 1. When it is an unloaded machine, the load angle will be 0. After the application of load, the angle will be increases from 0 to delta 1. So this is the first swing of electrical power developed. So this power is equal to the mechanical load. How much the load will be impacted suddenly, so that load is equal to the swing electrical power. So in this condition, the equilibrium is not established. Again the rotor will be swinging. So that means the angle will be changing from delta 1 to delta 2. So now the electrical power generated is greater than the previous one. So previous one ಅಲ್ಲಿ ಏನು ನಾವು ಆ ಲೋಡಿಗೆ ಈಕ್ವಲ್ ಅಂತ ಏನು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪವರ್ ಹೇಳಿದ್ವಿ, ಆ ಡೆಲ್ಟಾ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ so the electrical power generated is also increases. So the rotor will be attains synchronous speed, but it will be not maintain the synchronous speed because of the creation of the load angle increases. So it does not stay in synchronous speed and it will continue to increase behind the synchronous speed. So ಏನಾಗ್ತದೆ, ಈ ಪ್ರೋಸೆಸ್ ಇಂದ ಆಂಗಲ್ ಡೆಲ್ಟಾ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆನೆ ಏನು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪವರ್ ಜನರೇಟ್ ಮಾಡ್ತಾ ಇರ್ತದೆ, ಸೊ ದಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ದ ರೋಟಾರ್ ಸ್ಪೀಡ್. ಆ ರೋಟಾರ್ ಸ್ಪೀಡು ಏನಾಗ್ತದೆ ಅಂತಂದ್ರೆ ಸಿಂಕ್ರೋನಸ್ ಸ್ಪೀಡ್ಗಿಂತ ಜಾಸ್ತಿ ರನ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. ಸೊ ದ ರೋಟಾರ್ ನೆವರ್ ರನ್ ವಿತ್ ಎ ಸಿಂಕ್ರೋನಸ್ ಸ್ಪೀಡ್, ಸೊ ದಟ್ ವಿ ನೋ. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್. ಆಸ್ ಅ ರಿಸಲ್ಟ್ what will happen? The rotor will be acceleration above the synchronous speed and again the load angle will be decreases. Once again no equilibrium is attained. So these type of rotor swings or oscillates about new equilibrium position. So this phenomenon is known as hunting or phase swinging. So next, what are the causes of creating a hunting in a synchronous generator? So when the machine is already in running conditions under no load, suppose if the load will be connected suddenly, so due to that sudden increase of load, the rotor will be swinging. So this is one of the causes. There is a sudden change in load. So that will causes the hunting. Suppose if the field current in the alternator will be suddenly changes, the flux creation will be changes, the EMF induced is also changes, so that will be impacted on that rotor and again there is a chance of the hunting. And also the load torque containing the harmonics, so that is also one causes for creating a hunting. Suppose if any fault will be occurring on the system, again there will be a load on the rotor and the rotor will be crossing the synchronous speed. So then also there is a chance of hunting. So the faults were occurring in the system which the generator supplies, and also the cyclic variation of the load torque. The load torque is not constant, it will be changes according to the rotor speed. So that is one of the causes of hunting. So next, what are the effect of hunting? So due to this hunting, the system may lose synchronism. So once it will be losing synchronism, it is very difficult to make the reliable operation of the system. And also it will produces the higher value of mechanical stress in the rotor shaft. And also large mechanical stresses may develop in the rotor shaft. So causes greater surges in current and power flow. So behind the limit, the current will be increases and also the power will be flows in the system. And also it will be increases the possibility of resonance. So there is a chance of resonance. So due to that resonance, again there will be a chance of creation of a surge current. And also it can cause the variation of supply voltage producing undesirable lamp flicker. So that means the voltage will be varied and the system will not get the stabilized voltage. So there is a chance of the lamp flickering. The possibility of these resonance conditions increases if the frequency of the torque component becomes equal to that of the transient oscillation of the synchronous motion. Resonance may takes place. Next, how to reduct or how to prevent this hunting. So the hunting can be reduced by using any one of these two methods. So one is by use of damper windings method. The second one is by using uses of flywheels. So next, how to prevent the hunting by connecting the damper winding in the pole faces of a silent pole alternator. So these damper winding consisting of a low resistance copper or aluminum brush. So these will be embedded in the slots of pole faces of a silent pole machines. So the damper winding function is to, it will be damps out hunting by producing a torque opposite to slip of rotor. What is the torque developed in the slip of rotor? Opposite to that torque will be created with equal magnitude by using these damper windings. The magnitude of these damper torque is directly proportional to the slip speed. So in synchronous motion, the damper winding is placed on pole face of the rotor and the two sides will be short circuited with a thick copper bars. Suppose when the load on the machine is suddenly changed, the rotor will be start oscillating because of the presence of magnetic inertia. So about the new equilibrium point. However, these oscillation produced due to this swinging will be dies out because of the presence of a damper winding. So these during hunting there is a relative motion between the rotor winding and synchronously rotating magnetic field will be taking place and it will damping out the creation of surge under application sudden application of a load. And this whatever the damper winding will create a EMF. So according to Faraday's laws, this current will flows and according to the length it will be opposes the sudden change in cause. However, these effect will be induced current in damper winding and causes a relative motion. So like that it will be damps out the surge will be created in case of a hunting. So this is the pictorial representation of a damper winding. So these are nothing but a non-silent machines and this is nothing but the portion where we are providing a damper winding. So this damper winding always connected in series with the main pole ahead. So this will creating a equal and opposite EMF to that of the original poles or original magnetic field. Next, we have to discuss some multiple choice questions regarding hunting. So we have now familiarized with the definition of hunting and causes of hunting, how these hunting will be prevented with the help of a damper winding. So the first question is, hunting in synchronous motion can be reduced by using number 1, damper bars, flywheel, machines having suitable synchronization power, all of these. So we have discussed only two methods of reducing the hunting, that is by damping and also flywheel. So the machine, those machines have produces a synchronized power will also responsible for damping out of hunting. So therefore all these three options will be correct and the answer will be all of the above. The second question is, in large alternators, damper winding is used to improve speed, efficiency, stability, power factor. So because of the sudden change in load, the system speed will be changing and the system voltage will be changing. In order to bring back the system in a stabilized way, so we can go for a damper winding. So therefore the answer will be the stability of the system. So the next question is, in synchronous generator, the purpose of using damper winding is to reduce the hunting effect, reduce the armature reaction ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, provide starting torque ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, all of these ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So the thing is, in order to reduce the hunting, we are using a damper winding. Oscillation of the rotor about its new equilibrium position due to the sudden application or removal of load in synchronous motor is called what? Hunting, galloping, swinging, both. So it is A and C because the name will be either hunting or swinging. Answer will be A and C. Hunting in a synchronous motor results in loss of synchronism. Definitely it will lose us the synchronization effect and there will be a mechanical and electrical stresses on the rotor of the motor and a large current drawn by motor. So all of the above. So in a synchronous motor, the phenomenon of hunting caused by the sudden application or removal of load is prevented by, already we have discussed, that is by using damper winding. The hunting in synchronous motion can be guarded against by using flywheel, designing the synchronous motion with suitable synchronizing power, damped bars, all of these. Already we have discussed all of these. Use of damper winding in alternators results in elimination of harmonic effects, a low resistance path for the currents due to unbalancing of voltage, oscillations when two alternators are connected in parallel. All these things we have to reduce with the help of a damper winding. Next, in a larger generator, dampers, definitely it will be increases the stability of the system. So this is oscillation of the rotor about its new equilibrium position due to sudden application or removal of load in synchronous motor is called both A and C. So far we have discussed about the definition of hunting and what are the effects of hunting, what are the causes of hunting, how these huntings are prevented by using a damper winding. What are the different multiple choice questions will be arises while discussing the process of hunting and the prevention of hunting. So these are the references book what I have studied, and these are the my e-content development team members. Along with the help of these faculties, we have generated the e-content, and thank you for having this wonderful session.